Everyone, and welcome back to Brains Are Beautiful. In today's episode, we are going to learn all about parabolas. Now, if you stayed with us throughout all these series, you've probably heard about parabolas in the Algebra 1 section, but parabolas are so important in math. They just keep coming back, and so we're going to talk about them a little more in depth. But if you haven't seen any of the other videos or you don't know what a parabola is, go back to the Algebra 1 section, catch up on parabolas, and then come back to this video. So in this video, we're going to be talking about some different vocab that has to do with the parabolas that is really important for you to understand before you can jump right into them. And then we're also going to talk about some different forms of the equations and how to interpret what these forms mean. And I think this video is going to be really important because I remember learning this as a student, and it was really difficult to find all in one place, like everything about them, how to graph them, what it meant, the vocab, all this stuff. So this is all going to be covered, and I hope it's going to be really beneficial to you guys. So here we go. Okay, so first on the list, we have our vocab. So we have a focus, a directrix, an axis of symmetry, a vertex, and a reflector. So we're going to go through each of those, and basically all focus is it is a fixed point. A fixed, and feel free to take notes at home along with this, or else you could screenshot this when I'm done and print it out for your records. A fixed point, just basically a dot somewhere. I don't know if you guys could see that, but a dot. A directrix, on the other hand, very similar, is a fixed straight line or something linear. So a fixed straight line. And basically these two things are the building blocks of a parabola. Now the axis of symmetry, that goes through the focus and at a right angle to the directrix. So we're going to say through focus, sorry, that's an S, guys. Through focus and at right angle, that's supposed to be right angle, to directrix. Okay, we're just going to abbreviate it like that. So what I think of with the axis of symmetry is it's like you could fold it in half and have the exact same picture. So if you had a parabola like this, and the focal point was here, the axis of symmetry actually runs right through the center of that. And I didn't draw this very well, but basically where you could fold this half and this over this half, and you would have the exact same picture because it's perfect on both sides. So that's what the axis of symmetry does. The vertex. The vertex is halfway between the focus and the directrix. So we're going to say halfway between focus and directrix. So what this means on our picture, this is our vertex. I like to think of it as where it takes a sharp change, like a sharp turn, because it's going down, and then all of a sudden we start going up. And now one last really cool property of parabolas that is surprisingly neglected a lot of times. It's actually a reflector, and it means that any ray that's parallel to the axis of symmetry gets reflected back toward the focus. Sorry guys, it's a mouthful. So any ray parallel to the axis of symmetry gets reflected back to the focus. So we're going to say ray parallel, that's a parallel sign, to AOS, axis of symmetry, goes back to focus. So what that means, let me draw you guys a picture here. So what that basically means is as we draw a parabola, can we have, say this is our focus point, and then we're going to have our line of symmetry right like that. So any line, any ray that's coming in parallel to this axis of symmetry, it's actually going to hit the parabola and go back toward the focus. Hits the parabola and goes to the focus. Hits the parabola and goes to the focus. So what's really neat about this is that's actually why parabolas are used in society. I mean, you could see a parabola as a satellite dish or a radar dish, just to give some examples. It's a really cool property. I thought it was worth mentioning. Okay, so now on to the different forms of an equation. So we have a standard form. So we have standard, and we have a vertex form. Both are really commonly used. If you just came straight out of Algebra 1, you've probably only ever used the standard form, but vertex is really, really useful, which we'll show. The standard form is y equals ax squared plus bx plus c. And we actually derived this in another video in Algebra 1 by completing the square. And then we have our vertex form, which might be new to some of you. Y equals a parentheses x minus h quantity squared plus k. And you might be thinking, okay, great, so there's two equations. I have no idea how to use them or what they mean. Well, they're actually giving you that parabola. So if we draw a parabola down here, we have our focus point is always here, and our directrix will be here. Okay, and then we know in this case the axis of symmetry is that y-axis. And then this right here at 0, 0 would be our vertex now. And we're going to label our vertex. We're going to say that that is h, comma, k. All right, so we're going to start with the vertex form. And we already said vertex is h, comma, k. So that's actually already given in our equation. So that's really handy. So we immediately know where that point is. The other thing is we need to notice is A. A is really important. If A is positive, or in other words, if A is greater than 0, then we have that positive parabola, which is a U shape. And then if we have A is negative or less than 0, then we have that negative parabola. And how I remember this is if A is positive, usually positive people are always smiling. So you can kind of see that smiley face. And if A is negative, usually negative people are frowning. So there's that sad face. So that's one feature. One more feature for vertex form is actually has to do with A again. And that is whether the absolute value of A is greater or less than 1. So if A, the absolute value of A is greater than 1, we have a narrowing parabola. Narrow. And if the absolute value of A is less than 1, then we have a widening parabola. And what I mean by widening, narrowing, when we have parabolas, I'm just going to show you the widening example. Sometimes our parabola can look kind of like this, where it gets wider and wider the higher up we go. And that would be reminiscent of A is, the absolute value of A is less than 1. And then we come back over here to our standard form. This one's a little more tricky to get the actual parabola just by looking at it, but it's still just as useful. Vertex is actually only given at the x point in this, and it's x equals negative b over 2a. So this value on top divided by 2 and that number. And then you can plug that back into the equation to get your y value for the vertex. And we'll show this in examples in later videos. The other thing to note is when A is greater than 0, we have the positive or smiley parabola. And when A is negative, we have the sad or negative parabola. And that wraps up right now's video. And so please stay tuned for All About Parabolas Part 2, where we'll do some examples. And if this video helped you, please like it and subscribe to my channel. And if you have any questions, feel free to comment down below. Thanks, and remember everyone, brains are beautiful.